Trigonometry has a lot of identities. To master them, we start simple. The first identity that I can think of is this: tan theta is equal to sine theta over cos theta. And why is that? It's just the way tan theta is defined. If you consider the unit circle, and if there is a line that makes an angle of theta with the x-axis, and say it meets the unit circle in the coordinates of x and y, then sine theta is defined as the y coordinate and cos theta is defined as the x coordinate, and tan theta is defined as the ratio y over x. So tan theta is y over x. So that's why it's sine over cosine. And then we also want to know the reciprocal identities. So cosecant is the reciprocal of sine. So cosecant theta is 1 over sine. Then secant is the reciprocal of cos. So that's going to be 1 over cos. And cot is the reciprocal of tan. So reciprocal of tan means we need to flip this fraction. It's going to be cosine theta over sine theta. Now these relationships are telling me that of the 6 trigonometric functions, sine, cos, tan, cosecant, secant, cot, we can express everything in terms of sine and cosine. So we can work just with sines and cosines, and tan theta can be expressed in terms of sine and cosine, and the other 3 as well. We don't need anything beyond sine and cosine. So let's put all of these in a box that tell us that we could convert everything to sines and cosines. And once we have learned this, the other identity, it's called the Pythagorean identity, that we want to know is sine square theta plus cos square theta is equal to 1. Now there are other 2 Pythagorean identities. If you divide both sides by sine square and both sides by cos square, you get 2 more identities. But notice that when we have written everything in terms of sines and cosines, we also want to know how sine and cosine are related to each other. And it's related by this. And just like Pythagorean theorem has a square plus b square equals c square, we have Pythagorean identity for trig functions, sine square plus cos square equals 1. In fact, that's exactly what's happening here. Your a and b are x and y, and your c is 1 because the hypotenuse is 1. So Pythagorean identity. Now the other 2 Pythagorean identities are, if you divide both sides by sine square, you get sine square over sine square, which is 1, plus cos square over sine square is cot square, then 1 over sine square is cosecant square. And if you divide both sides by cos square, you're going to find that you get 1 plus tan square equals secant square. Now, if this seems like a lot, at least try to remember the 1 in the boxes.